Hi guys, I'm here to walk you through some concepts to think about for your CO2 cars. And then at the end I'll introduce the project. Well, I guess I'll introduce a little bit. You will be designing a car and it's going to be made out of wood. You guys are going to create the design as 3 different views, or 4, you might need 4 views of your car, and then we're going to tape them to a piece of wood, and then I'm going to take them up to the high school and cut them out for you and get them all ready to go, and then we'll bring them back here and you'll sand them down exactly how you want it and you'll get it perfect. We might spray paint it, and then we're going to definitely race them. Which will be really fun. And they use CO2 cartridges, and they just go in the back of the car. I'll show you an example maybe on Friday. And you put a CO2 cartridge in it, and then it's super fun. We'll race them with something to measure the speed, and then we can calculate how fast your car goes in miles per hour. I know. So what we're really looking for is we're going to research, meaning we're going to be introduced to lots of different topics and things to think about when we design our car. And we're really going to start looking at aerodynamics, which is how solid objects displace fluid, air, and other gases. Specifically air for us, because we're talking about how how the car is going to move through the air. Then we're going to look at physics, and that's talking about how different things move. And then tribology is just the study of friction, and we might go through that a little bit, thinking about how to reduce friction in our cars. So we need to understand that we are really I'm looking for a design that is well thought out, shows that you've thought about the elements of aerodynamics, and you are going to be judged on how fast your car can go. You are going to have to be limited to different things just because of our block of wood. And then you're going to have to think about what we're learning and using it to the best example. And we will be testing your solution, hopefully, against other classmates. So in aerodynamics, you have fluids and mass and aerodynamics. Fluid is talking about if you're moving through something. It's talking about the motion through a liquid. Mass is talking about how much something weighs. And then aerodynamics is, again, the way that the air is moving around an object. You have drag, meaning how, that's talking about the force slowing down the car, throwing the air. Lift is how much the air is pushing back. And rear suction is how much the end of your car moving the air differently around it can make the air suck down and push it forward faster. And then downforce is like gravity. So how gravity is affecting how your car is moving. And then frontal area is talking about the front design of your car. So with aerodynamics, you have air, and that is talking about how it can be directed or displaced. It has mass in terms of pressure. So it is made of particles, and those particles weigh something. And it applies direct and frictional forces to objects in motion. Even yourself, when you're walking, you have some air drag. So you should be aware of drag, lift, downforce, drag coefficient, and the frontal area, which we're all going to be talking about. So drag is the combination of 2 forces that will work against the acceleration of your car. It is the frontal pressure, which is when tiny molecules of air, which is just air molecules, hit the front of your car and are forced away to make room for other molecules to hit it. So it's talking about how something will move, how the air particles move over the car so that more air particles can come in and follow it behind there. And then rear suction occurs when an empty pocket of air is created in the back of your car, resulting in a vacuum cleaner effect, and tries to pull your car backwards. I was wrong. I'm sorry. I spoke wrong a second ago. It's not pushing your car forward. It's pulling it backwards a little bit. So let's look at this picture. So we've got drag here, and you've got that frontal pressure going up and pushing each particle over so it can come up. Lift is talking about when the the air particles are moving in an upward direction, meaning you're getting your car to go faster, kind of like an airplane lifts. Downforce is when gravity affects it, and so that's when the air particles are going to slow down. The colors are speed, so red being slow, yellow, orange being medium, and green being fast. And then back here is that rear suction that occurs because the air particles are coming off the roof of the car, coming and circling and making this vacuum here and here. So you can think of this like when you are drinking something out of a straw. The liquid gets pushed up when the air pressure balance changes. So when you're sucking through a straw, you're removing the air that's at the top of the straw, and then you've removed that air pressure, and it goes up. So when you remove the fluid air from the surface around your car, the air pressure causes the empty space to be filled in by the weight of the atmosphere, which is gravity. Oh, I'm sorry, that's atmospheric pressure. I'm all sorts of struggling. So again, that's that rear vacuum that occurs. It's coming off the off the top of the car, and the air just goes down and creates this suction, pulling the car backwards. So you want your lift to be greater than that suction that's coming in the back. So it's similar to that. Lift is similar to the rear suction, that a thin empty pocket occurs as air passes over a flat surface, causing the car to lift, and you do want that lifting motion so that the car moves forward instead of getting sucked backwards. And downforce is due to the high pressure and curved surfaces that causes the car to push down. That's that gravity affecting it. So let's look at how that windshield, and that's really just a flat surface, any sort of flat surface. When the air moves and gets stuck in that flat surface, it doesn't have anywhere to go. Now, if you create a little spoiler towards the end, that creates a high pressure area that pushes down on the rear of the car. And that's generally, it's okay because it's pushing down, so it's kind of canceling out this volume, this vacuum area that's happening here. But notice how that does change the direction the air is flowing. Think about when a ball is in motion. So the ball comes this way, but the air is flowing this way, opposite of the direction of the ball. When it rotates in motion, so it's going this way, causes the air around it to flow with the rotation. So the air comes and flows with the rotation. So the ball should have been just going this way, but because it needs air, it changes and flows a little bit more this way in the flight path. And that's because of that lift and downforce action. Golf balls have these really fun, little dimples in it, and that's for reducing the friction with the surfaces. So that's a really interesting idea. Drag coefficient is talking about how slippery the car is. So the more ways you can eliminate drag and turbulence and rear suction, lift and downforce, the faster your car will go. So you just have to think about how you might try to eliminate some of those different forces that happen so that you can have a more efficient car. You are totally welcome to look at different car designs. I want you to be creative with this because it does not have to look like any traditional car design, but it can instead be something really fun and interesting. Now, frontal area is the total surfaces in the front of your vehicle that can cause drag. So to figure out the frontal area, you take the length and the width. So let's make the area of this rectangle here, and you multiply it, and that'll give you your area for the frontal area. The smaller number you have here, the better. So which do you think? With one hand, do you think a football or soccer ball can be thrown farther? Choose one. Got it in your head? The correct answer is football because it has less frontal area, so it doesn't have as much of that drag that comes up, and the air can just go up and over. With the soccer ball, it's got this large area that kind of just gets stuck. I know. So some tips to avoid. You want to avoid the upright surfaces in the front of your car to reduce turbulence. You want to avoid flat upright surfaces in the back so you don't have that rear suction happening. You want to shield as much air at the bottom of your car to maintain traction. So keep the bottom of the car super flat. And you want to keep the surface area exposed oncoming air to a minimum, or at least it can be. Let's think about this again. Can you hit a baseball or softball farther? Correct answer is baseball because it's smaller. What about a golf ball? It's even the smallest, and it can go the farthest between baseball, softball, and golf ball because it's the smallest and it's got those dimples to reduce traction. Now with physics, you have force and acceleration. Force is just talking about the mass times the acceleration, and force is how much energy you need to move something. Acceleration is how fast it's going to be moving at any given point in time. So a heavier object requires more effort to move at the same speed, and it's easier to push a CO2 car out of the ditch than push an actual car out of the ditch, right? That makes sense. So with bicycles, you have like mountain bikes. They're really durable, they're really good for rough terrain, but they take a lot more energy to move up a mountain or up a hill even, versus a super light like trekking bike. I can't remember what they call them. But they're fast, they're really good for long distances, and they use less energy than a traditional mountain bike. So you want to think about the weight of your car when you're designing your car as well. The angle of your CO2 cartridge. Now this is something that's going to go in the back. So you can go so that it's pointing down, and look what happened. The front of the car goes up. If the CO2 cartridge is this is pointing up, the car goes straight down. If it's going straight across the cartridge, the car stays level and goes straight across that way. I know it's kind of hard to see on those. You want to avoid unnecessary extensions or ornaments that will add weight to your car. These are the reviews, sorry. The lighter your car design will be, the more power you get out of the CO2 cartridge and the less energy it takes to move. This is a fun little picture to think about what's going on there. And make sure that I will do this, but you have to make sure that your CO2 cartridge goes in straight. These are just the review tips again. The same ones that we just saw. And then you're going to paint your car. We'll hopefully paint the car if we have time. I'm not going to let you play with the axle design. And I'm not really going to let you play with the wheel design either. So that one's taken away. And that's why we didn't go over that last turbology aspect. But hopefully this gives you a good idea on the start of thinking about your car design.